Hello explorers! Today I'm trying to help my friend with filming a video. I also have a YouTube channel, which is less regular than my friend. So today I was thinking that we should go ahead and learn a little bit more about the lambdas that Daniel showed us some weeks ago, I think. And the project I'm going to use to show how to use lambdas in a more production-ish or library-ish environment is a parser. It's going to parse and calculate some addition from a string, so it's not that complicated. It's also not that cool that I would like to, but we'll get there. But let's start with the easiest things first and kind of ease into it. So I have some code here, which I will soon delete. But this is the result we're looking for today. So if I do like this and delete all this code, then we can start from the beginning. So what we want to do here is to parse a string. I'm also going to show you the util classes I have written. They are very small, so it will take very little time. So if I go to the parser interface, the parser interface here is just a shorthand to make it a little bit easier to write method declarations. So in this case, a parser is a function, it extends function, and it takes a string as input and returns the result of t. T here is a type placeholder. So if I have a parser that the result type of the parsing is integer, in this case it will return a result of type integer. So what is a result? A result is just a class that holds a value and the source that is left to be parsed. So you can see here that it takes a t here, and t is the value, and the constructor takes the source and the value, and it stores the source and the value. And there's also a utility method here that's called map. You maybe know about map from the functional world or maybe from the Stream API. And it takes a function that goes from t to o and creates a result of type O and just passes the source. So we're going to use this when we have a string of something and we want to create something more Java-esque. Maybe, yes, we're going to use it to make an integer later. But now back to the main. So here we have parse. We have not defined the parse method yet. So I ask the IDE to create the parse method. And I know that this is going to be an integer. So I'm going to say int. And yes, it's a string. I'll call it source. So what's the first thing we're going to do here? Well, we're going to say we want to return a plus parsing plus, can call it plus s maybe, and it's going to take the source and we're just interested in the value. So pluses, we don't have the method pluses, so let's create the method pluses, and pluses return a result of type an integer. And it takes string type source. Let's hide this so we know we don't need that. And what we want to do here is to first get a result of type an integer, which is the first integer there. And this integer we'll call first. And to get the integer, we'll parse a number. So number source. And after that number, we want to have a result that is a character. And it's the plus. And we'll parse a plus. Seems quite simple, right? But here we cannot use source. We'll ask for first source. I'm actually gonna rename this variable here because it's much better to call it left over. And we'll say that's okay. So method call expected? Well, we'll ignore that. Result. Here it said plus somewhere. Shouldn't have done. Anyway. Result integer. Second. And it's also a number. And we need to return a result here, so return new result. And we'll ask ourselves, okay, so what's left from the input? So the second is what's left. So what's left over from the second is also what's left over here. All right. So it's not source, it's plus dot left over. And then we want the first value plus the second value. I hope this makes sense to you. So let's call this P just to make it not so angry at us. So I hope this makes sense. So we have some method that we haven't written yet that finds a number, and we have some method that finds a plus, and we have some method that finds a number, which is the same as before. And we just feed the source to the other one, and we collect the values that we're interested in. So let's do the number here. So we create the number method, and it knows the type, and it knows the variable source. That's good. So here we want to return digits, because we want to parse digits, but we want to map the digits to integer parse int source. But we don't know how to parse digits yet, so we'll create that one. And that's the result, index source. And it creates a string of digits. String, right? So right now we're gonna try. Let's try to parse. Wait, we first want to have a digit. And then we'll try to parse digits. These like digits. And if this succeeds, we'll return ds map. The string and d dot value plus string. And I think we'll actually need that. But if it fails, we'll just return d.map. It's a character, so we'll do. So this is a bit odd. This is a shorthand, you might say, to convert something to a string. So characters plus empty string becomes the string of that character. And then we could, so we have a string here, and then we add the other digits that we've parsed. So this is kind of a recursive parser. So we'll try recursively until we fail, and then we just return the rest. And I hope I've done this in the right order. I might have missed. So how do we parse a digit? We create a digit function, and it knows all those nice things, and we return a match. Let's do parser dot match, and let's do character and C should be greater or equal to 0, 0, and C should be less or equal to 9. So that is a digit. And we then need to apply source. But we don't have a match. Let's go to the parser. I don't know why it doesn't let me do this, but static match parser char match pre. There's something wrong with my computer. I don't know what, but it has been quite hot. And I can't spell the character. So return a parser that takes out the char. So s dot char at, interested in the first character of the string, if test p dot test. A predicate is something that tells some truthiness about something, in this case of a character. So check if the truthiness of this char according to the predicate is true, then return new result of s.substring and we start one character ahead and s.length, and then we do chr, and this should have a better name. So let's name that to leftover, just to be more what's the name in English? Consequent in Swedish, anyway. Move it up there. Else throw runtime exception, because that was what we were listening to. And normally you would actually say something good here, but hey, it's just an example. This will never bite us in the back. No, it will always work. Wise words that almost never is true. So we were using this somewhere. Let's go and watch here. And it seems like all types align. Sometimes using these kind of fancy pants stuff feels like having a puzzle with the types, sometimes called type Tetris. But at least when everything is correct, it mostly always works, which is the good stuff. Right, okay, so we have a way to parse digits, a single digit, we have a way to parse digits, we have a way to parse number, which means that it's a digit which is converted to a integer. We have a way to parse pluses, which is almost true. Let's give this a name plus sign, because I think that's better. And let's create that one. Create a plus sign. And the plus sign, yes, sounds source. Sounds really nice. Return. And since we did the match thing, we can do parser match and say, well, if the character is equal to plus, that's awesome. Sure, we need to apply source. Let's do it like that. We could actually do this. What did this do? Oh, that's ugly. Let's do much better. Okay, do you have any errors in the file? Yes. You don't need to import that. Okay, so does this work? I think this is short command to run. No, short command to, let's do it here. Run main. So it should be 14, right? And it worked! So this was a quite fast-paced tutorial in writing a parser that understands pluses and numbers. And you can see that there's some refactoring potential. This pluses actually only are able to do one of the pluses, and actually it would be nice if the parser could try to parse something that is not a plus. Like if we do like this, it will fail, I think. Let's not try it. So there's a lot of potential. And if we would continue with that, we would need to do some refactoring, I think, to make it really nice. Have a utility method or function that takes a parser and can parse multiple times that, so we can extract this behavior. We could also do, which you usually have, a utility method that says, okay, parse as many of these as you like, and if there are more than one, it should be divided by these. And this way could create a quite easy language DSL for parsing. So that was everything for me today, and hopefully it will be a new episode where we do all the things that I've been talking about right now. And that's all. Bye.